Hello guys, welcome to Bluetech Empire Python tutorials. In these tutorials, we are going to be looking at the looping constructs, the while loop. Now, the while loop is very important if you have a block of code you like to execute when a particular condition is true. For example, you may want to accept input from a user till a negative value is entered by the user, or maybe the value quits is entered by the user. If you have used console programs before, you realize most console programs will receive inputs from a user, and they usually say press cure to quit or something like that. So most of these programs are running on a loop, and even embedded system devices, all this, if you've ever heard about Internet of Things and all these embedded system devices, for example, if you program the Arduino kit or the Raspberry Pi, most of these, or even the PIC microcontrollers, most of these embedded system devices automatically run within a loop. Means the code keeps running, and each time it runs, different conditions, you set up different conditions based on the input of your sensor value. So while loops are very important if you're processing data, if you're dealing with embedded system devices, robotics, and even data analytics, real-time data analytics, you'll be able to use while loops for a lot of stuff. So we are going to be looking first at the structure or syntax of the while loops. So let's look at that right now. So here is an example of the general structure of the while loop, or the flow diagram of the while loop from jigs.com. You see, so you see the structure of a while loop is not very complicated. We just have basically three parts: the while statement itself, and then we have what we call a test condition. This can also be called a conditional expression, but we can call it the test condition, the conditional expression, or just basically the condition. So now the while loop tests this condition. It means it executes this conditional code, and if it results to false, the while loop terminates. If it results to true, the statement or the code block or the block of code within the while loop is executed. We call it statements or code blocks. It's executed, and the statements, the test expression is executed again. If it's true, the statements will be executed. The test condition is checked again. If it results to true, the statements within the body of the while loop will be executed. At any point where the test expression or condition expression results to false, the while loop will be terminated. Immediately, you can note something about the while loop. If the test expression is false initially, the statements of the while loop will never be executed. In other programming language, we have what is called a do while loop. But with Python, you can implement that. But in Python, we don't actually have an explicit do while loop, which means a do while loop is different from a while loop. If you've done other programming language, where the statement first executes at least once before the text expression is checked or the condition expression is checked. So at least the statement must execute once, then the text expression is tested, and if the text expression evaluates to true, then the statement will be executed again. An example of a do while loop is if, for example, you want to collect input from a user and you say enter your password, for example, and then from there now you check if the password is correct. If the password is wrong, you keep telling the user wrong password, enter your password, wrong password, enter your password, until the point where the password is true, then you exit the while loop. So that's the example of a do while loop, because in the do while loop you need to first tell the user to enter a password. So that's the do part, and the while part tests the password to check if it's true. Then if it's false, it continuously executes the while part, and if it's true, that's if the password is correct, you exit the while loop. But in this case, a while loop, if the test expression or the test condition or the conditional expression is false initially, the statements will not be executed. While if it's true, the statements will be executed. It's tested again. If it's true, it will be executed at any point where the test expression gets to false. Then the loop will be terminated, or the loop will be terminated, and execution will continue from below the loop. Now you can immediately note something about the while loop. It's easy for a while loop to enter what we call an infinite loop. For example, if the test expression always evaluates to true, the while loop will run forever. We call that an infinite loop. We are going to look at that later on, but for now, just know you need to be careful with while loops. Make sure the test expression at a certain point will result to false, because if it never results to false, you're gonna get into an infinite loop, and this can run down the memory of your computer or crash your program. All right, now so let's look at some few examples of the while loop. Let's get started with using the while loop. All right, now look at this example where we are trying to print even numbers from 1 right up to 100. So we started printing out the even numbers, but as you realize, so at some point at line 13, we got tired because, we'll need to do about quite a number of this. So, programming languages are very efficient, so there must be a way to solve this problem. If you want to print from 1 to 100, there should be a way for us to do it within 3 lines of code or somehow. That's when looping constructs came into place. It allows you to do a series of things or to carry out a series of execution and based on a condition. At the point where that condition becomes false, you now stop that process. So implementing this in procedural form or without loops is quite complex, so we are not going to be doing that. But let's say in case we have to like use a loop to do this, then it's going to be very simple. So let's look how we can convert this piece of code to a while loop. Simply, we have to say, okay, we want to start printing from 2 to right up to from 1 right up to 100. So it's simple. We can have what we call a start should be equals to 1, and we have end should be equals to 100. It's very simple. We just say um, while let's say then let's have what we call value. So value is equals to start. All right. So no. So value equals to start. So we just say while value while value is less than 100, or while value is less than or equals to end, because 100 is part, and continue print if value mod 2 is equals to 0, print value. Okay, print line, let's say print line value. Let's see now. We just want to, because line 2, line 4, and the rest. So want now let's see what happens at this point. All right, and take notes. Now look what happens if we do this. We are going to get into what we call an infinite loop. For example, look what's happening. In fact, it's an infinite loop, so it's not going to run. But let's increment value equals to start, value less than or equals to n. If value is less than or equals to n, y value is less than or equals to n. So now what we'll do is we increment value by 1. Value equals to 1. So all right. Now look at this. All right. So we have 2, 4, 6, 8, and right up to 100. So here's what I want you to take note. Here is a while loop example. You see, a long code, we have simplified it into a very short code of a while loop. First, like I told you, we have the conditional expression. It can either evaluate to true or false. So let's check this out. Let's see whether it evaluates to true or false. So let me explain to you what this means if you have not watched our video on conditional expressions. Let's look what this value less than n gives. So we have we had value. Let's say we had value at 1. Let's check 1 less than or equals to 1 less than or equals to, let's say at the point end was 100. You see it's true. Let's check 10 less than or equal to 100. You see it's true. Let's now check 101 less than or equal to 100. It's false. So what happens here is, as you can see, what happens here is what happens here is simple. Now, initially we have a start, we have the value 1. Now, what happens in the while loop is the value initially here is 1 because value equals to start is 1. We check the while condition, like I said, this is the conditional expression, the first part. You can put it within parentheses if you want, just to make it clear. This is the first part. Now, which it's a condition. If it's true, the body, here is the body of the while loop. Take note of the indentation from the left margin. You see 4 spaces or a tab character. So this here is the body of the while loop, this statement. And we can even have the end of the while loop to say print thanks, just to indicate where the end of the, to really show you we reach the end of the while loop. So you see thanks at the end. So what happens is the body of the while loop has a conditional expression like we did. If you haven't watched our video on conditional expression, you can watch the last 2 videos. Now, I think the last 3 videos I will talk about the if, elif, and else statement. So now the if statement actually has a conditional expression too, like we saw in the video. So it checks if value mod 2 is 0. Now this is to test for even or odd numbers. For example, mod 2 is the remainder when you divide the value by 2. For example, look at something. If you say 4 modulus 2 gives us 0, but if you take 5 and divide by 2, you have a remainder of 1. So every even number, for example, modulus 2 will give you 0, while every odd number modulus 2 will give you 1. So that's what we're actually doing here. With test, we can say value modulus 2. In case the value is 1, you give us 1. In case the value is odd, you will not give us 0. So whenever value mod 2 gives us 0, we know we are dealing with an even number. So it means value is an even number. So we print that even number out here. Now we increment value by 1. Why are we incrementing value by 1? If we don't increment value by 1, we are going to have an infinite loop here. Because remember, value initially is 1, so value will always be less than 100. But as we keep incrementing value by 1, as some value will move from 1, the next time the loop is iterated, remember this is the end of the loop. This print statement is not the body of the loop because it's not indented at the same level with the other statements. It has the same indentation as the while loop. So this is the end of the while loop. So at this point, the condition is tested back. and if it's true, the body is executed and the condition is tested back. If it's true, the body is executed. The condition is tested back. If it's true, the body, remember this is the body. This statement is not part of the body. I just wanted you to know this print statement is not part of the body. The body ends where the indentation ends. I explained this in the if statement. So the body is executed. So you see here we have value mod 2. Here it checks if this is an odd number, we print it, we increment. At some point, like I explained to you in this just recently, at some point value is going to become 101. And 101 is not less than 100. So this statement is going to be false and the while loop is going to be terminated and execution will continue from below the while loop, which is the print statement. So basically, that's how the while loop works. The next example we are going to be looking at, I'm not going to be explaining a lot in details of this structure of the while loop because I guess at this point you understand the while loop tests for its condition. If its condition is true, the body is executed. At the end of the body, the while condition is checked again. If it's true, the body is evaluated again. And within the body of the while loop or within the while loop code, you must be incrementing. You must make sure you change the test condition in such a way where at some point it evaluates to false, except you are writing an infinite loop where you never want the loop to end, and you won't like to do that in the typical program that runs continuously, except your program receives input from the user. So let's go into more details, or let's look at more examples of the while loop, so you properly grab the concept of the while loop. So let's look at some other code here. So consider another code, counter equals to 0. All right, so in this program, we actually using what we call a flag. So now we have two identifiers of variables. I don't know what's all this for. Written about first. All right, so we have two identifiers of variables. We have counter. Let me clear this output here. We have counter, which is assigned to the object with the value 0, and we have this done assigned to the object with the value false. All right, so first we have a conditional expression for the while loop, and it's test if done is false. Of course, done is done false. Initially, done is false. So as you can see, done is false. So the while loop will be executed, and we increment counter by 1 each time the while loop is executed, and but we check a condition within that. After we implement counter by 1, we check if counter is greater than 10. Let's use greater than 10. If counter is greater than 10, you see we set done to true. This is very important because like I told you, you must make sure at some point the while condition or the conditional expression should evaluate to false. This is true because done is false. So done equals to false is true. If you don't understand what I'm saying, let me show you at the beginning. Let's say done is equal to false. Check the condition. If you said done is done equal to false, you see it's true. I just want to show you. So initially this is true, and let's see, but at the point where we set done to true, this is going to be false now because done, if done is true, then done equals to false. If done is true, then done equals to false is going to give false. I just want you to see that. So at the point where we set done to true, this statement will give us false, and the while loop will continue from this point. So let's check. Let's see how this runs first, so you understand what I'm doing. Yeah. Okay. So you see, we are still up and running. Let's add something. Let's add a counter here so that you actually see the value of counter, so you know what is happening properly. Let's try it now. Okay, so you see we are still up and running 0. At this point counter is 0. After counter goes to 1 because we're incrementing it. At the point counter goes to 10. Now at the point, let's say at the point where counter is 10, done is equals to, you see here we said if counter is greater than 10, so done will still execute with the counter 10. Done is equal to false is still true because this condition here was false. This condition here will still be false. That's if done at the point where counter is equal to 10. Remember, we're incrementing counter for every iteration of the loop. You know, continuous execution of the loop is known as iterations. So for every iteration of the loop, you see we're incrementing counter by 1. At some point, counter will be 10. Now, if counter is equal to 10, counter greater than 10 will still be false because 10 is not greater than 10. 10 is less than or equal to 10. So, 10 is equal to 10. Yeah, 10 is equal to 10, or 10 is less than or equal to 10. But 10 is equal to 10. So 10 is not greater than 10. So what's going to happen is this will still be false. But at the 10th iteration, okay, I'm sorry, at the 10th iteration, let's say at the 9th iteration, this counter plus equal to 1 will make counter to become 10. So this will be false. So this loop will still execute because done will not be set to true. But now when counter is equal to 10, at that iteration, at this point where counter is equal to 10, this counter plus 1 is going to set counter to 11. And counter greater than 10 is going to be true now because 11 is greater than 10. So done will be set to true. Now, when the loop tries to execute again, it checks done equals to false will be false because done is now equal to true, like I showed you here. When you set done to true, done equal to false will be false. So because this condition is false, eh, because this condition is false, the loop will be terminated and will have end. Now, if we call done, we normally call this variable done, we call it a flag. Now, it may be difficult for you to understand, so let's set it to -1. Let's say if done equals to -1, it's easier to understand because in most programming language we use the flag -1. So let's say if done equals to um in this case now we set the flag, it's still going to execute the same way. Let me show you. All right, so let's say if done equals to -1, done equals to 1, while done not, sorry, while done not equal to -1. All right, all right. So in this case, we'll continue executing all this, or let's say all this, as long as done is not -1. But remember, at some point when counter is greater than 10, within our the while code, we set done to -1. At the point where we set done to -1, this statement becomes false because now done is -1. So done not equals to -1 is going to give us false. Or if you want, it may be difficult sometimes to understand, but let's say done equal to -1. If you write done not equal to -1 is false, right? You understand? So you're trying to say done not equal to -1 is false because done is equal to -1. Okay, so in this type the condition is going to be false. Or if you say, you can say not done equal to -1. Okay, you're trying to say why done is not, you can use this too and it's going to work. Let's see, I think this will work. Sorry, the done statement here. All right, so all right, you can still use this. You can say not means you say done should be equals to -1, but putting not there is what we call negation. So you're saying if done is equals to -1, you're taking the negation of this statement. So if for done is equals to -1, not done equals to negative. If done equals to -1 is true, not done equals to -1 will be false. So at this point, you're saying done should not be equals to -1. Then you want all this to be executed. But at the point where done now becomes -1, this statement here is going to be false, and the loop is going to be terminated. So let's look at more examples for you to understand this. I know these are complicated conditional statements if you're new into programming, but I would like you to watch our video on conditional expressions if you have not done that. Or yeah, conditional expressions where we study the not statement, the or statement, or logical expressions. Yes, I think logical expressions will be very important for you to watch that so you can understand what I'm doing right here. So let's look at more interesting examples of using the while loop so you can see more scenarios where the while loop can be used. So here is one of the simplest example you can see for those who don't really understand what I've been doing all through. I guess this one is going to bring you up to this point. So here we have count equals 1. There is our test condition, or let's say that we have there our sentiment value or a flag, sentinel value or a flag. So it's also called a flag or the sentinel value. It's, we are actually testing it. The while loop depends on this value. That's why we call it a flag. Especially when you're dealing with embedded system devices, we use flags a lot to program microcontrollers and all this. So as you can see here, we have count. We're testing count. At this point, you already know count is less than 10. It's true. Let me show you so you understand. Let's say count equals to 1. It's count, let's the statement count less than 10. It's going to give us true. So as you see at this point now, after we print count, what we do is we increment count by 1. So count now becomes 2. The while, remember, this is not part, line 7 is not part of the while statement because of the indentation. The while statement, all the codes within the while statement have the same indentation, as you can see, 4 spaces from the left margin or 4 spaces from the indentation of the while loop. So if the while loop is at this point, for example, all the codes have to be, the while loop codes have to be 4 spaces. And once the compiler finds a code that has the same indentation level as the while statement, it knows that's the end of the while loop. So let's just go back. Just wanted to show you that. All right, so we increment count by 1, and the while condition will be tested again. If it's still true, we increment count by 1. So at a certain point, count becomes 9, and we test is count less than 10. Yes, 9 is less than or equal to 10. We print 9. Now we increment count to 10. Now the while condition test is 10 less than or equal to 10. Yes, because 10 is equal to 10. We print out 10. Now we count is incremented to 11.
So let's see how this code is going to execute. All right, so there we go. You see, it prints from 1 because count is 1. After count goes to 2, it prints 2. After count goes to 3, it prints 3. But at the point where count goes to 11, this condition code or condition expression, it's going to be false, so the loop is going to be terminated. So at this point, I hope you're able to understand how we increment or we change the sentinel or the flag value within the loop code or within the while code, so that at some point the condition of the while loop should evaluate to false. Remember, this is very important, or else you're going to end up in an infinite loop. Make sure within the while code at some point the value or the test condition of the while loop is going to be false. You have to do that and take note of that. That's very important, so you don't get into what we call a while loop. That's a source of error in many programs written using loops. We always have, even with a professional or whatever your level, you always have this kind of problem where you forget to increment or change the sentinel value within the while loop, such within the while, the code of the while loop, such that at some point the test condition of the while loop evaluates to false. So always remember to do that. So now let's look at some other example using while loops. Let's say var equal to 2. All right, so here is a simple program. We see we are trying to print the square roots of, as you see, we have var 2. We are trying to print var squared. So we are printing the square of every value from 2 right up to, let's say 20. Now I'm going to show you something right here. Let's execute this program so you see how it executes. All right, so you see we have 2 squared is we square from 2 to 20. Now you mustn't increment the sentinel value or the flag by 1 or the test value by 1. You can increment it by any number. 2, you can subtract from it, you can increment it, whatever. So let's say, for example, if we're adding 2 to it, see what happens. The first time is going to be 2, second time 4, 6, 8, and at some point you see, so at some point when it gets to 18, when you add 20 again, it's not less than 20, because 20 less than 20 is false, because 20 can only be equal to 20. So 20 is not less than 20. All right, so um at that point you see it prints from 2 4 6. That's because every time we increment that value by 2. So here's a simpler example for you to understand. Here is the sentinel value the while loop depends on. So at some point, since we're incrementing this value every time by 2, at some point this value is going to be let's say 20, because it's going to move from 2 4 6 8. As you can see, its initial value is 2. As we add 2, it's going to move from 2 4 6 8, and at some point it's going to be 20. When it's 20, var less than 20, which is 2, 20 less than 20 is going to evaluate to false. So the while loop is going to end and execution is going to continue from line 7. So I hope you understand that. So let's look at another piece of code. All right, so here is the program. Okay, so here's a simple program. Initially, we have a list identifier. It points assigned, that's list 1. It's assigned to the list containing a couple of values, the list object with a couple of values. Then we have len 1, which is equivalent to the len of the list. Now I just want to show you something. Len 1, as you can see, len 1 should be 0 1 2 3 4 5, because if you have a list like this, so just so you see, normally I'm not supposed to be doing this. If you write len this one, you see it's 5. So len 1 will be 5. And now when we create, if we say list 2 equals to list range list 1, now list 2, let's check, let's see, so you see what's happening. Let's see list 2 now, list 2. So you see, we create a list that equals to range from 0 to 30. You understand? So list 2 Take note, list 2 is equals to list. We create range from 0 to 30. So like I told you, if you watch the last video on the range function, you'll discover this creates from 0 to 2, 4, 6, 8. It has gap of 2. So if you haven't watched the range the video on the range function, watch it. But this is what is going to be generated, a list of 0, 2, 4. So I just wanted you to see that. So now we have cn1, that's our counter 1. So we want to print list one item. So we say while cn1 is less than len of list, so like len of list is 5. So this is the test condition now. While cn1 is, that's why cn1 initially is 0, it should be less than 5. We print index cn1, that's the value of cn1. Index 0 is, then we index the list. If you haven't watched our video on list, you can watch it. We index the list. So the first time is going to be list 0, which is 1, list 2, which is this, list 1, which is this, list 2, which is this, 3, 4. At the point where and remember, we are incrementing the sentinel value by 1, so that at some point this condition is going to be false. So initially it's going to start from 0, then it's going to go to 1, 2, 3, 4. At some point when you reach 5, this condition is going to be false, because remember from here, as you can see, the length of list 1 is 5. So at some point where you reach 5, 5 is not less than 5, because 5 is equal to 5. So this will be false, and the loop will continue from this point. Execution, the loop will be terminated, execution will continue from line 14. Now next we have cn2 now. Now we say why cn2, which is 0, is less than len2. Remember, len2 is the length of len2. Where's len2? Len2 is the length of list 2. So let's check len2 here. Let's do it. So I just want you to see what's happening in the code. So let's check len2 now. You can see len2 is 15. All right. So so this will be why cn is less than 15. As you can see, it starts from 0 and indexes the list right up to 14. Remember, it starts from, at this point you can see we indexing list 2, which was created here. I showed you list 2. Here is list 2 that will be created. Yeah, so list 2 will be created here. Is 0, 2, 4 right up to a point. So you see 0, 1, 2, 3. We are indexing the list right up to the length of the list, which is 15. But remember, we started from 0, 1, 2, 3. So at 14, cn, at this point at 14, the list will be executed. But when cn2 is incremented to 15, 15 is not less than 15. So the loop is going to be terminated, and execution is going to continue from line 21. And at line 21, you see we have loop ended. So here is just a basic example of loops. I hope with this example you're beginning to grasp how while loops can be used in a real program. So you see here we have two while loops, this one at line 11, and we have another one at line 8. So you can have multiple while loops on your code, but make sure the sentinel value or the flag is incremented every time or decremented. But at some point the loop condition should evaluate to false, or else you get into what is known as an infinite loop. And usually infinite loop are usually logical errors or errors within your code. So be very careful with infinite loop. They can really cause you a lot of problem, and sometimes they are very difficult to debug or realize when you face an error. All right, let's look at some more stuffs on loops. Let's now write a program that keeps counting a counter, or keeps incrementing a counter up to a point where the user decides to end the loop. So here we are going to be using a sentinel value, which is a character or a string, and we are going to keep checking the sentinel value. Once the user enters a particular character, we are going to keep the loop. So initially we are going to start with our counter, and we initialize it to 0, and we have our entry, which is initially the entry should be yes, yes. So then following that, let's write our while loop. Okay, all right. So here's a simple program. um Let me try to explain a little bit, then we see the output. So here we have entry initially is a character, it's y, uppercase y, but we want the user to be able to use lowercase y or uppercase y, or lowercase n and uppercase n. So initially we test if entry is not equals to n. Here you see we use the AND operator, that's the logical AND operator, to test for, to apply multiple conditions. So true and true. This will be equivalent to true only if both expressions are true. This should be true and this should be true, because you know false and true is false, true and false is false, false and false is false, but true and true is true. So this conditional statement will evaluate to true if both expressions, that left hand side and right hand side expression of the logical and operator, is true. So let's try it out. So if this is not equal to, initially, yes, entry is not equal to n, neither is entry equal to n. So this is true and this is true. So initially the while loop will be executed. It's going to print counter, which is 0. Now entry is going to collect some input from the user, tells the user to use y to continue or n to quit. If the user enters y, it continues. If the user enters y, that's if entry is equals to y or lowercase y, counter plus equals to 1, we keep counting. If entry is not equals to n, in this case we say if entry is not equal to n, it means if the user enters any other value apart from n or n, we tell the user the choice is invalid choice, but we keep counting. Now we go again, we check if entry equals to n or n, the while loop will be terminated. That's because if entry not equals to n and entry not equals to lowercase n, that's entry not equals to uppercase n and entry not equals to lowercase n, the while loop will continue. So let's see an example so you get what I'm saying. So as you can see at this point, it asks us for a value, so we can say we want to continue, we want to continue, we want to continue. We enter G, it tells us G is not a valid choice. All right, we want to continue. Once we get we want to continue, we want to continue. You know, we can use capital letter, uppercase letter too. Let's say we get N now, quitting done. So that's because at this point, this point where we entered N, this condition failed. It became false because entry is not equals to n was true because we did not enter uppercase n, but entry not equals to n was false because entry was equal to n because we actually entered lowercase n. So since true and false is false, the general conditional expression equates to false. So the while loop, the code will be terminated, or the while loop will be terminated and execution will continue from here. That's why we see quitting done. So I hope you were able to understand from this example. Also note me using since I had to use single quotes within this string, I made sure I delimited the full string with double quotes because I know I'm going to use single quotes in it. And here I had to use double quotes like here. So I delimited the string with a single quote. We already did this when we studied strings. If you haven't watched the video, you can watch it. But here I'm just trying to explain the while loop. So I hope with this example, you're able to understand how while loops actually can be used in real programs. All right, so let's look at another example using while loops. So you really grab this concept. Okay, let's write a program that's going to collect some entries from the user. All right, so let's check if this is correct. All right, so as you can see, here is a piece of code, a simple piece of code. You know, this code has two variables which are important. Now I'd like to show you. I'd like to explain their purpose. So we have entry. Entry initially is where we like where we store the input by the entered by the user. Is actually an identifier, and the positive sum is an accumulator. It acts like an accumulator. In programming, an accumulator is a value which we add to it over time. Usually if you're entering inputs in a loop, we add to that value over time. We call it an accumulator. So initially we tell the user to enter some input, and now we begin to check entry. While entry is greater than 0, greater than or equals to 0, initially entry is equals to 0, so greater than or equals to 0. We collect some input from the user, we convert it to an integer, and we assign entry to that object. That's the object entered by the user. So initially, let's say and now if the user, if we check and that entry value is greater than or equals to 0, we add it to positive sum. That's add it to the accumulator. And if it's less than 0, automatically what's going to happen, if it's less than, 0 automatically, this condition is going to be false, and the loop will be automatically terminated. Because, for example, if the user enters -1, entry greater than 0 or equal to 0 is going to be false, and the loop will be terminated, and sum is just going to give us the positive sum. So let's see an example of how it works. So for example, let's say we get 5, 5. Let's see, 5, 5, 5, and 7, 7, 6, and some point we enter -1. So you see it has sum equals 16. Now we can let's say we can make it look obvious by just adding something here, so you know it's actually asking for more input, because the way it was, you may not immediately understand what was happening. So let's say, for example, enter 5. You see, we enter 7, we enter 9, we enter 7, we enter 3, we enter 7, and we enter -10, of course. Oh, let's see, entry value. All right, so we made a mistake on the last value. So let's try it again. 5, 7, 8, 9, and -1. So, or let's say -10. All right, so our sum is 33. You see, at the point where we enter the negative value, entry is equal to that negative value. So we said if entry is greater than or equal to 0, so this is not going to be, this if code will not be executed, because entry is -10, and -10 is not greater than or equal to 0. So of course this will not be executed. So we will not add -10 to the accumulator, because that's instead going to subtract from the accumulator. So automatically, when this condition is tested again, it's going to be false, and loop is going to be terminated, and we're going to just print this line will be executed. That execution is going to continue from line 12 downwards, and we're going to see sum 33. So here is a simple program that uses an accumulator, and it has a condition, the entry value. And you can see the conditional, that's the condition, like the sentinel value or whatever, is being changed within the code. It depends on what the user enters. So every value the user enters is going to be tested. After it's going to be tested here, both in the if condition is going to test it to know whether to add it to the accumulator, and also the while loop is also going to test it to know whether to quit or to continue. If it's negative, the while loop is going to be quit, and if it's positive, it's going to be added to the accumulator, because the while loop is going to continue execution, and this will be true. So I hope, as you can see, I hope you'll be able to understand this program. All right, so let's look at something else. All right, so let's talk about definite loops versus indefinite loops. So consider this example where we have count equals to 1. All right, now look at this example. We see we have, while count is less than or equals to 10, print count plus equals to 1. At this point, we can, right from the programming point of view, we can be able to know how many loops we are going to have. For example, I can say print how many loops are expected. We have 1, 2, 3. We have 10 loops expected. All right, we expect up to 10 loops. Let's see whether we're correct. Let's execute this. 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we predicted correctly. So a loop which you can predict the number of for a program, or for a looping construct which you'll be able to predict the number of iterations, is called a definite loop. As you can see, we knew this loop is going to execute 10 times, because we know the sentinel value, or yeah, we know the sentinel value, or the flag we're testing with. We know it's starting from 1 right up to 10. So of course, we know we're going to have 10 iterations. Now consider consider this second program. All right, so let's look at this program now. As you can see, we have count equals 1, n equals 2. We collect the n from the user. And then at this point, you can think maybe we can't know the number of iterations because we're collecting the input from the user, but we can know. For example, if we say um, our our iteration count can just be equals to n minus count, and can be equals to n minus counts, and we can say uh, print iter iter count iterations expected. All right, so we can write this expected. All right, let's look at this. Now, before the while statement, I want to show you, even though we're taking the input from the user, since once the user enters the input, we can know how many iterations we expect before the while loop is executed. So even though we collect some input from the user, we are, for example, if the user enters maybe 20, we're able to know, oh, sorry, this is supposed to be iter count like this. All right, so let's say 20. We had 19 iteration 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, we had 20, so we just iter count plus 1 iterations. So we just sorry, n iter count plus 1 iteration. So we're still able to know. We are still able to know. All right, 20 iterations. So as you can see, we're still able to know before the while loop the number of iterations we expect. Of course, you see we had 20. All right, now let's check. Let's look at another program to see. So because of that, because we're able to know the number of iterations expected before the while loop execution, we can still call that a definite loop because we're able to count, we're able to know the number of iterations before the while loop statement that's within our program, or before code execution, we're able to know the number of iterations expected. So it's still a definite loop. So let's look at another example. All right, so let's look at this program now. In this program, we have an initial value like a flag called finish. We set it to false. Now we say why not finish, which means why finish is always false, because if finish is true, not finish is false. So why we have not finish, we do what? We collect some input from the user. If that value the user enters is 99, you see we are already in the while loop. We set finish to true, and else we just print the value the user enters. So at this point, you see the loop is only going to stop executing once the user enters 99. Now we can never know at which point the user is going to enter 99 because it all depends on the user. For example, if I execute this, let me save this. If I execute this, um, let's just say enter input to make things better. All right, so let's all right, so I enter 5, it continues. I enter 8, it continues. At any point, you can never know at the point where I'm going to enter 999. Never. So we can never know when this loop is going. That's the number of iterations for this loop, because at this point I can enter 999 and the loop ends, but I can still enter 999 at the first position and the loop ends, or I can still enter 999 at any form, at any position. You can't know. So negative 4, you can't know, then 999. So such a loop where you can't know the number of iterations during at the point where you're writing the code, that's before the execution, code execution. Such loops are known as indefinite loops. You can't determine at what point or the number of iterations that the loop is going to occur for the loop. So each of those kinds of loops are known as indefinite loops. They're quite important to know because during your code execution, sometimes when you're writing more complex programs, you want to know if a loop is a definite loop or an indefinite loop because you may want to show certain values. So for that, I just want you to know the difference between a definite and an indefinite loop. All right. And this is important because the while statement is good for indefinite loops, while as we'll be seeing in the next video, we'll be talking about the for statement or the for statement for the for loop. You're going to discover the for loop is good for definite loops, while the for statement is good for definite loops, while the while statement is good for indefinite loops. Once there's a definite loop, when you're able to know the number of iterations expected, it's preferable for you to use the for statement. If you can't be able to determine the number of iterations, it's preferable for you to use the while statement. So while statement is good for indefinite loops, while the for statement is good for definite loops. Now, you may be wondering why I use integers, for example, as the sentinel value, not a float. For example, I don't say while x is greater than 0.2, do this. No, this is because floating points have different precisions. In Python, floating point numbers are actually saved with limited precision, and sometimes the Python is not able to save. For example, if you say 1 divided by 3, you see we have 0.33333. This can go right up to the end. 1 divided by 5, you see it's 0.2, good precision, but 1 divided by 7, we're going to have some long values. So sometimes Python is not able to handle values with definite precision. So once if you use a decimal point test as a loop condition, what's going to happen is that value can be passed with a different precision. So for example, let me explain. You can easily get into an infinite loop if you're not careful. So I'm going to show you why this is important. So you understand. I'm going to show you why this is important right now. Let's look at some program here. All right, now look at this piece of code. As you can see, um, we have some issue here because we actually use the sentinel values float. So it looks good. We have initially the var is 0.1 and we incrementing var by 0.1, which means it's going to move from 0.1, 0.2, 0.3, 0.4, 5, 6, 7, right up to 1.0. So at the point we expect at the point where var is equals to 1.0, this statement is going to be false, or we can say while not var equals to 1.0, or yeah, so we can see why not var equals to 1.0. We expect the code to end. So, but because I already know what's going to be have to happen, I actually have a limited number of iterations here. So initial limit is 1. Once we have an iteration of up to 30, I use the break statement to end the loop. We are going to look at the break and continue statement in another video, but I just put here, so I just did this here, so we should not have an infinite loop. But let's look what happens when we run. So as you can see, it's my finish. Because of my limits that the loop ended. As you can see, we had up to 3.0. Why? Because we moved from 0.1 to 0.2 to 0.3 right up to, you see, instead of having 1.0, Python represented it as 1.09999. So this is what I'm talking about when I say Python uses, Python doesn't cannot save most floating number with exact precision. So you see, instead of having 1.0, Python had 1.0999. So this condition here was never met because we thought by adding only 0.1, we are going to have 0.1, 0.2. But look, instead of 0.3, look what we had here. Instead of 0.7, instead of 0.8, look what we had. Instead of 0.9, we had 0.999. So when you're using float, you should not use exact values. You can use something like less than. If, if let's say if var is greater than 1.0, you end. You understand? In that case now, you don't need this because once var is greater than 1.0, the loop will be finished. So as you can see, here is it. So at that point, when bar was 1.0, the loop ended. So never use the equal to sign with a floating, like a conditional statement with a floating point value, because you're not sure of the precision Python is going to use to store that value. All right, so I just wanted to show you that it's not good to use a floating point value as a sentinel value or as a flag, because Python doesn't save floating point values with exact precision. So take very good note of that, or else sometimes you're going to get into an infinite loop. And if you want to see an infinite loop, here's an example of an infinite loop. Let me show you. Without this, we're going to get into an infinite loop. So as you see, if we execute this, you see we just get the code just keeps running. So I have to find a way to stop this now. But this here is what we call an infinite loop. It never stops, just continue running, and it can consume all the resources of our computer. All right, so let me stop this. Yeah, so I stopped that. So like I said, instead of using equal to sign or the not equal to sign, you can use something like less than or equal to sign for a range complete. So in this case, you see it will be executed normally. And since we did not have exactly 1.0, but at the point where we had so anything greater than zero, for example, 1.09, like we had the last time, it's going to be terminated. The loop is going to be terminated. So I just wanted you to see that, so you understand. All right. So at this point, I think that's basically what you need to understand about loops. I know this video has been quite long, but I just wanted you to fully grab the content. So see you in the next video where we'll talk about the for loop. All right. So have a nice time.